All right, well, I'm busy having fun canoeing and fishing and riding horses and whatever else at Outlaw. You guys are going to be learning about the graphs of linear inequalities. I want you to notice we've been graphing linear equations up until this point. Now the key word that you should be noticing when you're taking notes today is that we are graphing linear inequalities. So it kind of goes back to what we talked about earlier in the year with equations versus inequalities, and we did a little bit of a review activity for that for those of you guys that were here on Friday, graphing inequalities versus solving equations. So some review to begin with, and then we're going to dive right into graphing linear inequalities. And the nice thing is a lot of this relies on your background knowledge. As long as you're paying attention and you have that background knowledge, it should be a pretty good couple days. Real quickly, first thing I want to do is just check a couple things and make sure we understand how to tell whether an ordered pair is a solution of an inequality. At this point now, instead of having inequalities with one variable, you'll see we're going to have inequalities with more than one variable, just like we've had equations this entire unit. So instead of 2x minus 3y equals 6, we now say that 2x minus 3y is less than 6. Just like on Friday, there's infinitely many solutions here. I just want to check and see if an ordered pair happens to be a solution of that inequality. And remember, the easy way to check this is just using substitution. I put the 0 in for x, and I'd say 2 times 0 minus 3 times, put the 1 in for y. 2 times 0 minus 3 times 1. And I'm checking to see, is that less than 6 or not? Well, 2 times 0 is 0, and 3 times 1 is 3, so I have 0 minus 3. My question is negative 3 less than 6? Well, yeah, it is. Now, that doesn't mean that's the only solution. There's actually infinitely many solutions, but remember, that doesn't mean that everything works. It just means that there's infinitely many. So, for example, another ordered pair that I have here, 4 comma negative 2, you guys could check and see if that is a solution of the inequality. Plug the 4 in for x, plug the negative 2 in for y, and see if it works. Well, let's check this out. 2 times 4 minus 3 times a negative 2, is that less than 6? 8 minus a negative 6, is that less than 6? And remember, to subtract any number, we can add the opposite. So I'd say 8 plus 6 gives me 14, and it turns out 14 is not less than 6, so no, that is not a solution. Again, both of those should be pretty straightforward, just checking your background knowledge. What we're more interested in for the rest of the day is graphing linear inequalities. We're going to graph linear inequalities. You see kind of a rough sketch here on the title page, and you're going to see a little more of what I mean as we move on. So really what you need to understand is, what is a graph of a linear inequality? I want to get this into my notes. The graph of a linear inequality is the set of points, the set of all points in a coordinate plane that represent all the inequality solutions. Remember, the key here being that there's all the inequality solutions because there are infinitely many. And that's something that you have to definitely expect. The only way we really solve linear inequalities, or the only way we really show their solutions, is by graphing. That's why graphing these are such a key. So we're just going to show all the ordered pairs that work. For example, we found one ordered pair that did work, one that didn't. But remember, there's still infinitely many out there, and I'd like to see them. And to see those, I'm going to use a graph. We're going to graph linear inequalities. Real quickly, before we dive into the key to this, we're going to just review what we did on Friday and what we did earlier in the year as far as graphing one variable inequalities, because the background knowledge here is going to be pretty critical to what we do here in class. So I'm going to graph the inequality x is less than negative 3. X is less than negative 3. Well, I'm going to use a number line. And so I draw my number line, and of course I have arrows on each end of my number line, and I'm going to put that 3 value right in the middle, because that's the value that matters most to us. That's our boundary line. Remember, to the right I would have 4, and I would have 5. To the left I would have 2, and I'd have 1. And then this is why we're reviewing this. A couple key parts. We always ask ourselves, is it open dot or closed dot, and then does it go to the left or to the right? You're going to come back to that a lot when you're graphing linear inequalities. But I'm looking at open dot or closed dot. Notice it says x is less than 3. It can't be 3. It has to be less than 3. So that's when we had open dots. Remember, when it wasn't equal to, we had an open dot. That'll help you a lot with today. And then we had values less than 3. Less than would be to the left. If we're talking x values, they get smaller to the left. So there's just a quick example of how to graph inequalities with one variable. Now we're going to graph inequalities with more than one variable. And so notice, star this in your notes. Make sure you get this down. If Mr. Moore needs to pause the video for an extended period of time, we'll get this down, because this is the key to graphing linear inequalities. If you get this down in your notes, you're going to be good to go. First and foremost, like we've always talked about, we're going to want to keep in mind when we have something like slope-intercept form. If we have slope-intercept form, it's pretty simple to graph these. We're still going to identify an M. We're still going to identify a B. We're still going to use the starting point, then we're going to use the rate of change, and we're going to graph from there. The tricky stuff is keeping track of these signs that you see out here. These are the inequality signs that we're used to. Notice, the sign will tell us what kind of line to draw and where to shade. And so one thing that I draw your attention to is, if you notice, each of these with the equals, less than or equal to, greater than or equal to, notice they will have solid lines. They will have solid lines. If I can be equal to something, it's kind of like a closed dot. We'll have a solid line if it can be equal to that value. The other way to look at it, if I can't be equal to, notice, if it has to be less than or it has to be greater than, then we'll have dotted lines. Then we'll have dotted lines. So you got to actually keep track of your signs. Is it going to be a solid line or a dotted line? Can it be equal to or not? Then the second set of questions that you're going to ask yourself, am I going to shade above or am I going to shade below? And you'll see what I mean by shading, but you got to pay attention to this shading. If I'm greater than, if you notice on these last two, if I can be greater than that value, it's talking about y values greater than, so I'm going to shade above. Y values get bigger to the top. If I'm less than, like these first two, then I will shade below because y values are smaller below. Again, don't need all this color coding for your notes, but definitely want to get this information down because this really serves as a cheat sheet for you when we go to graph these. We want them in slope-intercept form. We're going to look at the symbol, and we're going to go from there. Let me dive into an example, and I think you'll see what I mean. I'm going to graph the inequality. Y is greater than or equal to 2x plus 4. Y is greater than or equal to 2x plus 4. Just like we talked about, we're looking for equations in slope-intercept form so we can identify the slope and we can identify the y-intercept. Notice we should see that this is in slope-intercept form, and we have an m of 2, and we have a b of 4. If it helps you, remember you can make this into a fraction. That's 2 over 1. Just like before, still going to start at the y-intercept and still going to use the slope to graph. So I'm going to start at 4, and I'm going to use the slope to graph. I'm going to go up 2 over 1. Keys for graphing inequalities. Fill this screen. Fill this graph. Because remember, we want all the solutions for the inequality, and there are infinitely many. So I'm really trying to fill this graph. And then I'm going to go ahead and put the arrows on the ends because I'm actually going to talk about the line that we're going to draw next. So I know I'm going to have arrows on the end, but now I need to decide what kind of line I have. To decide what kind of line I have, I'm always going to look at the inequality symbol. This is greater than or equal to. And so if I look back on my cheat sheet and I find greater than or equal to at the very bottom here, it says we're going to have a solid line and we're going to shade above. What we're looking at here, I want all y values that are greater than or equal to the line we just sketched out. It can be equal to this line, so it should be a solid line. We're going to fill in these dots. That's a pretty darn good line, too. You guys are welcome. Look at that. I have a solid line because it can be equal to, and now I need all y values that are greater than this line. Well, where would I find y values that are greater than this line? Y values get bigger above, so I'm going to shade above. And this is what I mean by shade. I'm going to try to fill in this graph and really show all the solutions that work for this particular inequality. Any ordered pair that is up here is a solution, would work. Anything above that line or on that line will work in that inequality. Anything below, any ordered pairs below, will not work and are not a solution. So that's graphing linear inequalities, using the cheat sheet, using slope-intercept form, understanding the idea of we're comparing y to that line. So let me give you another example. As you look at this, it says x plus 2y is less than 6. Notice this is not in slope-intercept form, and so our key, like we've talked about, would be to get it into slope-intercept form. So the first thing I would want to do is subtract x on both sides, and I'd say 2y is less than a negative x plus 6, trying to get it into slope-intercept form. Last step would be to divide both sides by 2 and divide everything by 2, and notice y is less than now a negative 1/2 x plus 3. I have my m, and I have my b, and I should be able to graph this, keeping in mind that we're going to have to keep track of what type of line it is. We'll come back to that later. Let's start with our m and our b. So we go to the y-intercept of 3, and we use the slope of a negative 1 over 2. Remember, that's change in y over change in x, down 1 over 2, down 1 over 2, down 1 over 2. And again, like I said, really trying to fill the graph so we can see all the solutions that work and all the solutions that don't work. I'll put the arrows on the end here because we know it's going to go on forever in both directions. And now we're going to go back to that symbol of inequality again. I'm going to look at this less than symbol. Notice I want y values that are less than my line. And I ask myself, can it include the line? Can it be equal to the line? Because it says less than, it cannot include that line. And because it says less than, if you look at the very top here, we're going to have a dotted line only, and we're going to shade below. We want all y values that are less than that line, and they don't include that line. So I'm going to shade accordingly. Again, really trying to fill the graph, going nice and neat. Hopefully you guys learned how to color in kindergarten or so, and you can do a nice job at this. And you'll really want to be able to shade this neatly for next year when we do systems. But this is a really good idea of how we're going to graph inequalities. 2 examples where we use the m, we use the b, and then we just got to decide what kind of line and where do we shade. The last example that I'm going to give you for the video, I'm going to do 2 on the same graph because I want you to be able to compare some other types of inequalities that we see. This is not in slope-intercept form. This says x is less than 3. Well, to me, I want all values where x is less than 3. So I'm going to begin with a line that we're used to where x equals 3. We're kind of going to use that as our guide. We know that x equals 3 is a vertical line where all x values equal 3. So I'm going to kind of just mark that up and kind of see what I have here. Here's my x equals 3. This would be the type of line that we would have right here. When I do this, then I'm going to go ahead and put the arrows on the end, and I've actually looked at a line like x equals 3. Now I want all x values where they're less than 3, so I just need to ask myself, is it a solid line or a dotted line, and where are x values less than 3? Turns out I think we know x values get smaller to the left, and it's a less than, so it's not a solid line. I'm just going to leave it dotted, and then I'm going to shade everything to the left of that line. That's graphing x is less than 3. The second line that I want to try to graph is y is greater than negative 2. Y is greater than negative 2. Keeping in mind we're going to use that y equals 2 line as kind of a guide. We're going to kind of use that as a guide. And so we want to find where y equals negative 2. Well, y is negative 2 down here, and it's negative 2 all the way along here. Y also equals negative 2 all the way to this side. Remember, this is a slope of 0. It is a horizontal line at y equals negative 2. Then I look at the symbol of inequality. Y is greater than or equal to. It can be equal to, so I will make a solid line through here to show that that does include the line. And I know greater than means that we want all y values that are above this line. So I shade everything above this line, and I've got myself covered. Notice what we have here. Then we actually have 4 distinct areas on this graph. Where you see both the green and the blue, you have solutions of both. These ordered pairs, their x values are less than 3, and their y values are greater than or equal to negative 2. All ordered pairs in that region are going to meet both. Solutions over here would only meet one of the requirements. Here would be solutions of y is greater than or equal to a negative 2. They're greater than or equal to negative 2, but the x values don't fit. Here would be solutions to our first inequality, where x is less than 3. All of these, x values are less than 3, but their y values don't meet the other requirement. And then, of course, here you see that there's not a solution for either one. These ordered pairs, their y values are all less than negative 2, and their x values are all greater than or equal to 3. I know it's a little bit tricky, but I think if you really keep coming back to this cheat sheet here where you're looking for slope-intercept form and you're looking at the symbols of inequality, you really should be able to graph these today and should maybe be able to tackle the word problems as well. That should be graphing linear inequalities. That'll take care of Monday and Tuesday. When we come back on Wednesday, I'll see how we're doing.